circular cone with a shaded base, and we will try to derive a formula for the surface area of a cone. Let us name the points O, A, B. Points A and B are marked on the circumference such that AB forms a diameter. Let L be the slant height and H be the perpendicular height. And let R be the radius of the circular base. First, let us consider the circular base. The radius of the circular base is R, so its area will be pi r squared. Next, we need to find the area of the curved surface. And we have seen that when the curved surface is opened up, it looks like a sector. We also need to find the area of the sector. Let the sector be OAB. Look at the sector and the cone. What do you think is the measure of these two lengths? OA and OB will equal the slant height, which is L. Here's another interesting question. What will be the length of arc AB? This is an arc as we know that a sector is part of the circle. This arc is actually the circumference of the circular base. So the length of this arc will be 2 pi r. A sector is also defined by the angle it subtends at the center. Let us call it theta. Now we are ready to find the area of the sector. And it gets even more interesting. There is another way in which we can find the length of the arc AB. Let's zoom out to look at the other way. It will equal theta by 360 multiplied by the circumference of the circle with radius OA and OB. What will be the circumference of the circle that is formed with this as the sector? It will be 2 pi L, since L is the radius of the circle of which this sector is a part. This tells us that the length of arc AB is a part of the circumference of the big circle that can be formed here. But the length of arc AB is also 2 pi r. That will equal theta by 360 multiplied by 2 pi L. Cancelling 2 pi out from both sides, we get r equal to theta by 360 multiplied by L. The area of this sector will be the curved surface area of this cone. The area of this sector will equal theta by 360 multiplied by the area of the circle with OA and OB as the radius. And that will be pi L squared, as L is the radius of this circle. Can we write this a bit differently? Yes, this can also be written as pi L multiplied by theta by 360 multiplied by L. We have just split pi L squared into pi L multiplied by L. But this part in brackets, as we just found out, is equal to r. So the curved surface area will be pi L multiplied by r. Let us review what we just did. We found out the length of arc AB in two different ways and equated them. And then we found out the curved surface area using the formula of a sector of a circle. And then finally substituted the value of r in this formula to eliminate theta. Now it's very simple. The total surface area of the cone will be the curved surface area plus the area of the circular base. The curved surface area, as we know, is pi LR, and the area of the base is pi r squared. Both the terms have pi r as their common factor. Taking pi r common, we write the formula as pi r multiplied by L plus r. This is the formula for the total surface area of a right circular cone.
This is a birthday cap. Now you can see that a birthday cap is in the shape of a cone, a three-dimensional cone. Now suppose I want to know how this birthday cap is made so that I can make birthday caps for my birthday. So let me first see it from all angles. Now to make a birthday cap, I viewed it. See, from the bottom, it actually looks like a circular base. So this circular base is actually what? A circle. Now to find out how much paper will I require to make this cap, I need to know the circumference of this circle. Now what is the circumference of any circle? It is 2 pi r. So for this circular base, the circumference is same as 2 pi r. So the circumference of the circular base of my birthday cap is 2 pi r. Now let me view it in another angle. Now you can see that the birthday cap actually has this circular base as 2 pi r, and we know that any cone has a slant height, that is the distance from the vertex to any point on the circular base, that is called the slant height. So in my birthday cap, the circular base is 2 pi r and L is the slant height. Now let me open up this birthday cap and see how much paper is actually required to make this cap. See, we opened this. So you can see that we have cut out the cap and see that the circular base is having the circumference as 2 pi r, because this is only the base that we have cut out to make this curved surface area. Now we also know that the distance from this vertex to any point on the circular base is the slant height. Now I need to find out how much paper would I require to make this cap. So this is actually this amount of paper. So now how much paper will I require will be found out by taking out the curved surface area of this cone. For that, let us imagine that this is a sector of a circle. So you can see how we formed a circle from this sector. So this cone is a sector of this circle. Now this cone is having this circular base which has a perimeter of 2 pi r and a slant height of L. Can you notice one thing? This slant height is actually acting as a radius of this circle, because it is from the center of the circle to any point on the circular base. So this circular base only we have extended to make a circle. So this L is acting as the radius of this big circle. So what is the perimeter of this circle, or the circumference of this big circle? Can you tell me? Now the circumference of any circle is 2 pi r. So what will be the circumference of this big circle if L is acting as the radius? What we need to do? We just need to substitute L in place of this r, because here L, that is the slant height, is acting as the radius of this big circle. So instead of 2 pi r, we can say that the circumference of this big circle is 2 pi L. Here L is acting as the radius of this circle. So now we know that the circumference of this big circle is 2 pi L. Now can you tell me what will be the area of this big circle? Well, area of any circle is actually pi r square, where r is the radius of the circle. So again what we do? We take L as the radius of this circle. So we substitute L in the place of r. So what will be the area of this circle? Pi L square, where L is acting as the radius of this circle. So we found out that the circumference of this big circle is 2 pi L and the area of this circle is pi L square. So we can say that for 2 pi L units, that is the circumference, area of the circle is pi L square. This is what we found out. So for 1 unit, what will be the area of the circle? Simply apply unitary method. If for 2 pi L units, the area is pi L square, so for 1 unit, the area of the circle will be what? Pi L square divided by 2 pi L. Now for 2 pi r units, what will be the area of the circle? Well, what is this 2 pi r? See, this was 2 pi r. We have already found out that for the whole amount of circumference, this is the area of the circle. Now what about only this much? if I have the circumference as 2 pi r, then what will be the area of this sector? So what will be the area of this sector? Just by applying unitary method, we can write pi l square by 2 pi l into this, that is 2 pi r. So this is what we get. Now let's cancel out things. 2 gets cancelled, pi gets cancelled, l gets cancelled. So what are we left with? We are left with pi, l and r. So we can write this as pi r l. So we successfully found out what will be the amount of area that will be there for 2 pi r units of circumference. So this is called curved surface area of the birthday cap, that is the cone, which is pi r l. So if we take out the curved surface area of that birthday cap, we will be able to know how much paper will be required to make that birthday cap. So the curved surface area of any cone is what? Pi r l, where r is the radius of the circular base and l is the slant height of the cone. So now we have been given the dimensions of this birthday cap. Now the slant height here is 24 centimeter and the radius of the circular base is 7 centimeter. Now find out the curved surface area of this cone so that I can know how much paper will I require for this. Well, we know that the curved surface area of the cone is pi r l. So simply using the formula, we can find out the curved surface area of this cone. Pi is 22 by 7 into r, which is 7 centimeter, into l, that is 24 centimeter. 7 gets cancelled and we get 22 into 24, or we get it as 528 centimeter square. So the curved surface area of this cone, having the dimensions 24 centimeter as slant height and 7 centimeter as radius of the circular base, the curved surface area will be pi r l. That gives us 528 centimeter square. Now this is yummy. This is the favorite cornetto ice cream of all of us. Now you can see that this is the shape of the cone. Now you can very well understand how the cornetto companies pack these cones. Well, they use the curved surface area formula to take out the area of the paper required to cover this cone. Well, let's see. See, this paper is acting as that sector of the circle. So the area of this paper is actually what? Pi r l. We have just now found out this, that area of the curved surface of this cone is pi r l. So these companies, what they do, they calculate the area of this paper by putting in the formula pi r l. That is the curved surface area of the cone. Now is the cornetto covered only like this? Isn't it covered on the top as well? Well, yes. Along with this paper, it is covered with this circular base on top also. So now can you tell me how much paper this company actually requires to cover this cone? You can say that this paper plus this paper as well. So how to find out the area of this paper, that is the length? We know that the curved surface area is pi r l. That gives us the curved surface area of this cone. Now to take out this, what do we need? You can see that this is actually a circle. This paper is actually a circle. So any circle has an area of what? Pi r square. So to find out how much paper this actually requires, what we'll do? First we'll find out pi r l, that is the curved surface area, plus the area of this paper, that is pi r square. That is the area of the circular base. So this plus this will give us the total surface area required for this cone. So you can say that the total surface area of the cone is actually curved surface area of the cone, that is this part, covered totally, that is pi r L, plus area of the base of the cone. Now this is acting as the base of the cone. Here the cone is upright, but then this is actually the base of the cone. So this can be calculated with pi r square. So total surface area of the cone will be pi r L plus pi r square. So here we have been given the dimensions of this cone. Here we have been given that the slant height is 25 centimeter and the radius is 7 centimeter. So if I ask you to find out the curved surface area only of this cone, what will you do? You will take out the formula of pi r L and multiply pi with r into L. But then you know that the total surface area of this cone is actually curved surface area of the cone plus area of the base of the cone, that is pi r L plus pi r square. So now using these dimensions, find out the total surface area of this cone. Well, we can simplify this formula further. Pi r taken as common, we get L plus r. So now let us put these dimensions into this formula to find out the total surface area of our cone. Pi is 22 by 7 into r is here 7 centimeter into L is 25 centimeter plus r again, that is 7 centimeter. So now let's solve this further. 7 gets cancelled and we get 22 into 25 plus 7 gives us 32. Or this gives us 704 centimeter square. Why centimeter square? Because surface area of the cone is always represented by square units. So what did we learn? We learned that total surface area of any cone is actually curved surface area of the cone plus area of the base of the cone, or we can simplify the formula and write pi r brackets L plus r, where r acts as the radius of the circular base and L acts as the slant height of the cone.
Thank you for watching our channel. This video உங்களுக்கு பிடிச்சிருந்ததுனா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு பக்கத்துல இருக்கக்கூடிய பெல் பட்டனை ட்ரைன் தட்டுங்க. பை.